Welcome back to Coding the Sounds of Music. In this final video, which is optional, because boy, you've come a long way in learning how to code the sounds of music, we will learn how to use advanced Python methods and techniques to code an entire song in fewer lines of code than the way that you learned in the previous video. Play it again, Sam. Pause your video now and navigate to Challenge 10. On the next page, we'll see a pre-authored Python program that solves the same task as Challenge 9. It's going to play 2 bars of Twinkle. But you know, for a given problem, there's more than one way to solve it. You were tasked with playing 2 bars of Twinkle in the previous program, and it wound up taking you doing the same lines of code again and again. Many times, a program can be written in a way that is shorter, faster, and uses less memory. And these are all good attributes of a computer program. The bottom line is if your program works, that's great. And if you got the last challenge finished, kudos to you. But on this next page, we're going to review the code and try to understand how it works to give you a deeper insight into Python coding. There's also a task for you. There are a couple of notes that I've made a mistake on, and I want you to listen to the code, and I want you to try to fix it. Also, I want you to try to change the tempo to 160 beats per minute. So there's a couple of little fun tasks for you to do as you explore this program. Let's navigate to the next page. Control, clickpad to the right. Here is our program. Let's try to take a closer look and understand what each line of code is. Notice that I have included comments into this code. You can recognize a comment by the hashtag or pound symbol, and also you'll notice that it's kind of grayed out. This means that it's a note to the programmer and is not intended to be part of the executable Python code. Well, the comment, duration of 1 beat at 100 beats per minute. And look, there's our old friend, the calculation for beat time. Remember, we had been doing this using the scratch pad. But here, instead of using the scratch pad, it's actually calculated in the program. So right here, just this number in and of itself is the tempo. So to change the tempo, all you really have to do is change this number. Easy peasy. Also, it shows that the calculation for a whole note. Remember, we learned that there are 4 beats in a whole note. Well, we did not discuss the time signature of music, but 4/4 time means that there are 4 beats in a measure and the quarter note gets the beat. Well, not all music is in 4/4 time, and so this number right here helps us to determine the timing of the music, and it says, hey, a whole note gets 4 beats. We could change that though. If we wanted to change the time signature of this, all we got to do is change that number. Kind of cool. Well, what the heck is going on down here? Well, here it says this is 2 bars. We remember what a bar is. That's 4 beats, and it's separated by that vertical bar in the staff. And it says that this is 2 bars of Twinkle. But what the heck? If you look at this, there's a lot going on here. But you know what? This is actually all the music right here. So this square bracket right there, that square bracket, represents something in Python called a list. And a list is a kind of data structure. It's a way to store data in a variable in Python. And in this particular list, there are notes. And you'll recall that a note has a frequency, that's what C4 is, but it also has a duration, that's the kind of note, whether it's a quarter, half, or whole. And so in this case, we see that there is a note that is C4 that's played for a quarter note, that's one beat. Notice that it is in parentheses, these right here, these parentheses. When these two values, note name and note type, are in parentheses, it makes a kind of variable in Python that's referred to as a tuple. A tuple is a variable type that can contain multiple elements. So this whole thing is a list of tuples of notes. And notice that this whole thing is equal to a name called Twinkle. That's the name of my song. So you see, what I've done is I've created a list of tuples and I've defined it in the variable Twinkle. So Twinkle, when I just write Twinkle, it means all of this in here. Notice that all of these tuples in the list are separated with a comma. That means that these are individual elements within the list. So this whole data structure is our song. And this is one way that you could represent a song. And it's a very compact way of representing it. If you're familiar with the music technology called MIDI, MIDI is an electronic music form where there are computer files used to play entire songs. And in MIDI files, the music is stored in a way that's very similar to this. And now, let's figure out how to play that song. Right here is a control structure that we have not seen before. This is a for statement. And this particular flavor of for statement is for a list. We can find this under Menu, Built-ins, Control, and down here, number 7, for index and list. That's the statement that we're using right here. And what I've done is I said, hey, look, there is a list named Twinkle, that's right up here, and it has multiple notes in it that are separated by commas. What this control statement does is it cycles through every single entry in this list and it pulls it out of the data structure and it stores it in a variable called note. And so note is constantly updating as this for control loop cycles through all the values in it. This control structure will stop and exit when it has completed all of the values inside of it. So you can see that there's one, right? There's one note, 2, 3, 4, 5, 6. There are 7 notes in here. It's 8 beats because the last note's a half note. So that means that this for control loop will actually cycle 7 times. It's going to play a note, and it's going to play the note that is this tuple right here. And since this tuple has 2 parts to it, it has the actual note, that's the frequency, and it has the duration. So what it's going to do, 0, this square bracket in 0 is called an index. And that index points to one of these 2 positions inside the tuple. The 0 position is the first position. So it's going to play C4. So right here in this position, C4 will be substituted the first cycle through. This is the second position representing by the index of 1. It says 1/4. And so this is going to be replaced with 1/4. So 1/4 is going to be multiplied by this variable called whole. Well, let's remind ourselves what whole is. Whole is beat, which is this time interval. Remember, this is seconds. This 60 divided by 100 right here, this is 0.6. And so whole is equal to 0.6 times 4. That's 2.4. So whole has a value of 2.4 in it. So what I'm doing down here is I'm retrieving the note type, 1/4, and I'm multiplying it by 2.4, the value of whole. 1/4 times 2.4, well, that's the same as 2.4 divided by 4. That's 0.6, and that's the time interval for a quarter note. Okay. So then it's going to sleep. Remember, this is how we did it in our program last time, but we just hard-coded. That is, we wrote in the actual value of, say, C4 here, and we wrote in the actual time, say 0.6 right here. And then right here, we said, let's sleep for 0.6 seconds, and we repeated it 7 times. And so, 7 times 3, that was 21 lines of code. But here, we're replacing it really with, 4 lines of code. This comment doesn't really count. And so it's going to cycle through this 7 times. Each time that it cycles through, it's going to grab a tuple out of the list that has 2 parts, the note and the type. And it's going to play the note, that's the 0th or first position, and then it's going to wait for a time interval, which is the second position multiplied by the value of a whole note. Then it's going to sleep for that same interval of time, the value of the whole note multiplied by the note type in the list. And then we're going to sleep for 1/10 of a second to get the rest in between. So I threw a whole lot at you there. And what I want you to recognize is that this program looks very different from the program that you wrote. And in so doing, not only is it smaller in terms of how many lines of code is, but it's also easily changed. Like right here is where I can change the tempo. I just have to change that one number. It also allows me to change the time signature by just changing that number right there. And so it turns out that this program could be considered a better program because it's shorter, it's easier to extend to other scenarios, and it actually takes up less memory, even though we don't really keep too close a track on that, since this one, the previous program was 21 lines, and this one's not nearly as many, 1, 2, 3, 4, 5, 6, 7. And so just a different way of solving the same problem. And that Python is a very rich computer programming language, and there are techniques that you can learn to use in other coding classes that you may take that will help you to become a more efficient programmer. And I encourage you to stick with programming and learn all you can about it, because there's a lot of work in computer programming, and you're off to an excellent start. So take the time now to listen to the code and see if you can discover where in this list there is a mistake. One of these notes is wrong, and I want you to figure it out. And I also want you to try to modify the code to change the tempo. So pause your video now, complete the challenge, and resume when you're finished. Did you hear the 2 odd notes? Did you find my mistake? Well, I trust that you got it all coded correctly, and that you could also change the tempo in the program code as well. Well, this concludes the series, Coding the Sounds of Music. I've really enjoyed working with you in all of these, And I really hope that you continue to study Python coding, science, and STEM. If you liked what we did here, please check out our other projects at www.tistemprojects.com. My name is Fred Foch, and I've really enjoyed doing this with you. I'll see you again.